Hey guys, welcome back again. In this video we're going to be talking about compounding frequencies and how you can actually measure the interest rates in different ways. We're also going to be looking at the comparison of simple interest versus the compound interest. Okay, and we're going to be looking the differences between these two. And then we're going to be talking about the future value and the present value as well. Okay, the most essential time value concepts. And then finally we're going to be talking about continuous compounding as well. Okay, this is very crucial as a finance student, especially when you're doing FRM. You're going to be coming across continuous compounding a lot, so we will touch upon this concept as well. Okay, now the concept of compounding and compounding frequencies is something that you will see in this chapter reading number 40, which is from the Financial Markets and Product book, and reading number 54, which is interest rates, which is from this VRM, Valuation and Risk Models book. Okay, the learning objectives are quite similar, so we are doing it together. All right, let's begin. All right, so the next learning objective we have is 40B and 40C, and also if you look at it, 54A, it talks about the same thing. Okay, so we just have to calculate the value of an investment using different compounding frequencies, and we have to convert interest rate on different compounding frequencies. And if you look at this one from the VRM book, calculate and interpret the impact of different compounding frequency on a bond's value. Okay, so it's one and the same thing. It talks about the same compounding principles, but before we understand about compounding frequencies, it's important that we understand what exactly is the difference between the simple interest versus the interest that you get based on a compounding basis. Okay, this really makes sense. So let's first understand the conceptual understanding. Okay, so simple interest, in this, interest is levied only on principal amount every year. Okay, we're going to be taking an example. Similarly, if I talk about compounding, here we get interest on both the principal as well as the interest that you have already earned. Okay, in every periodic time. It is also called as interest on interest. Now this is a good way to actually remember what exactly we mean by compounding interest. Okay, so let's take an example here. Suppose we have invested $100 for a period of 5 years. Calculate the amount of money you will make at the end of the period if the simple interest is 5%. Okay, so the duration is 5 years, the amount that we have is $100, and it said that the interest that we are getting is simple interest of 5%. So let's calculate. So in year 1, that is going to be, we have the amount invested as 100, and we're gonna be getting 5% on that, so that's 0.05. now that is going to be $5. Okay, so this is the amount of money that, for example, if I draw this timeline, so in the very first year, if I invest $100 here, I will have $5 as the interest over here. Now in the year 2, we get interest only on principal. Okay, so it's going to be again 100, which is the principal amount that we have, again 0.05, that is going to be $5 as well. So again $5 here. Similarly, I can go ahead and I can calculate for year 3, year 4 and year 5, and I will get again $5 in each of these years. So the total amount of money that this $100 invested and the total amount that I get after the period of 5 years, that is going to be $25 in interest and $100 in principal. So the total becomes $125. Now this is the amount of money that we make at the end of 5 years. Now let's just compare for the compounding frequencies. Let's say that we have the same amount of money, the time duration is again 5 years, and we have to calculate the money at the end of the period if the interest rate is compounded at annually at 5%. Now over here we have compounding interest as compared to the previous example that we saw, in which we had simple interest. Okay, so let's calculate that. So in the year 1, we will have $100. This is the amount that we have, multiplied by 0.05, that is this interest rate, and we have $5 as the interest that we will end by the period end. Okay, so if I invest here, and this is year 1, so if I invest it here, then by the end, okay, by this period, I will have $5 as the interest amount that I've earned. Okay, similar to the simple interest that we have seen so far. But now here, starting from year 2, okay, this is where the magic begins of compounding. So in the year 2, we're going to be taking this 100, the investment, plus the interest that we have earned. Okay, so that is going to be 105 multiplied by the 5% of interest for year 2, and that is going to be $5.25. Okay, so what we have done, we have taken the amount of interest that we have already earned in year 1, we are adding to the overall principal, and on this we are getting the interest for year 2. Okay, so that is why I said that compound interest is interest on interest. Okay, that means you get interest on the interest that you've already earned, and that's the major difference between the simple and the compounding interest. So going forward to year 3, we have this 105 plus the amount of interest that we have already earned. Okay, so it's going to be 105 plus 5.25, so that is going to be 110.25, and on this investment we are earning 5%, so that is going to be $5.51. Okay, similarly I can calculate for year 4, that is going to be 110.25 plus this, that is 115.76 multiplied by the amount of interest, $5.78. and similarly I can calculate for year 5. This is how the calculation of a compounding interest looks like. So now let's compare the simple interest versus the compound interest. Okay, and as you can see, in simple interest we had the $100 as the initial investment, and we invested this for a period of 5 years, and we earned $5 interest every year for the next 5 years. Okay, and at the end of the period we had $125 as the total amount that we have earned. Okay, similarly we have the compounding interest. We had the same $100 to invest. The only thing that changed here is the interest that was compounded annually, and every year we saw that in the interest, it started to increase. Okay, it started to compound, and that is what the major difference. And at the end of the period we had a total amount of 127.61, roughly rounded off to 61, but this is the amount that we have as compared to $125. So it does make sense to invest in an investment that pays compounding interest, and we are able to get more money at the end of the period. And at the same time, if we are borrowing, it does make sense to borrow at simple interest because we are paying less as compared to the compounded interest. Okay, and one thing that I want to touch at this point in time, and I want you to understand, is that let's suppose that we have this bond basically for a period of 5 years. We are holding this bond. Now the only thing that is a major assumption when we're talking about the compound interest and is that of reinvestment. Okay, let me write it down. Now this reinvestment is a major assumption when we're talking about the compounding interest, because we are assuming that we are investing or perhaps reinvesting this $5 that we have earned here. Okay, at the end of the period we are investing for the second year, as you can see, and we are earning interest on the principal plus the interest that we have earned. So we are assuming that we have invested at the same interest rate, and this is a reinvestment concept, which is a major assumption in the compounded interest. And that is why when it comes to bonds, okay, reinvestment is a major risk. Okay, it is one of the risk that we have when it comes to bond investment. Okay, so I just wanted to touch upon this concept so that since we're talking about compounded interest, you are at least have a fair idea about the conceptual understanding of the reinvestment. Okay, all right, so far we have assumed that the interest happens annually. Okay, we've seen the annual compounding, which means we are getting interest every year. Okay, at the end of every year we are getting the interest. Now let's just say that, and this is also very practical in the bond market, and that is we are receiving interest semi-annually. Okay, this is a perfect example of a bond market, wherein when we buy this particular bond of, let's say, this 5 years, rather than getting interest at the end of the period, okay, right, like here we are getting interest every 6 months. Okay, every 6 months we will be receiving the interest from by purchasing this particular bond. So basically I can say that you're getting interest every 6 months. Isn't that amazing, right? So now the formula that we have already seen here, which is the future value, that is the amount you have multiplied by 1 plus the rate to the power t. Now this formula has to incorporate these different compounding frequencies as well. Now definitely this formula has to incorporate the semi-annual compounding and different compounding frequencies that we have. Okay, so the new formula, it becomes the future value that is equal to the amount that we have multiplied by 1 plus r divided by m to the power t multiplied by m. Now the m that you see here, this is the compounding frequency that we have in our example. So over here we have semi-annual compounding, which means two compoundings, okay, one here and the other one here in each particular year. Okay, so we have two compounding periods in every year, and that is why we divide this rate of interest that we get annually, this r that we have, the 5% that we have this interest for 1 year, right? So we divide this by 2 because it is a semi-annual compounding, and at the same time we multiply the period by this m. So the period that we have, or the time frame that we have, is 5 years. Okay, and each year we are getting 2 payments. Okay, so overall time that also is doubled by this m. Okay, so let's calculate the example that we have. $100 is the amount that we have. 1 plus 0.05, that is the rate, divided by m. In our example it's semi-annual, that means there are 2 periods, and the time frame is 5 multiplied by m is 2, and once we solve this we get $128.01. Okay, so this is the amount of money that we have at the end of period if we invest in a semi-annual compounding. And over here we had the answer of 127.61. okay, so this was the amount if we invested our money of $100, and we get at the end of the period we have this as a future value of 127.61. You can compare it. The semi-annual is definitely higher because the compounding period has increased. Okay, but let's get a bit further now, and let's just say that rather than getting interest every 6 months, what if I tell you that now within a year, okay, within a year you can get interest every quarter. Okay, every quarter you will get interest. Wouldn't that be amazing? All right, let's explore that. So in a year we are getting interest 4 times. So if I have 5 years, okay, so let's work out with this future value formula. So the amount that we have is 100, and 1 plus the rate of interest is 0.05 divided by m. Now m over here becomes 4 because within a year we have 4 quarters. Okay, so m here becomes 4 multiplied by 5, which is the maturity, the 5 years, multiplied by the m. In our case it's 4. And if I go ahead and if I calculate this, I will have my answer as $128.20. Now you can compare it that if I compound this thing annually, I have 127.61. If I compound the same money, the same time period, everything remains the same, but it's a semi-annual compounding, the amount is a bit higher. And if I compound it even further, the amount is also a bit higher than as compared to these two frequencies. Okay, so far what we have talked about is that we have seen annual compounding, we have seen semi-annual compounding, that is compounding every 2 months. We have also seen quarterly compounding, that means compounding every 4 months. Similarly, we can have a compounding frequency every month. Okay, so the formula will be 100 divided by 1 plus R divided by M. Now M in our case, in this case, would be monthly, it's going to be 12. T is it's 5 years multiplied by the frequency. So if I go ahead and if I calculate this, I will have monthly compounding as well. What I want to explore now is that, let's just say that we compound it so further that we actually compound every hour, every minute, even seconds, milliseconds, nanoseconds, so on and so forth, that it goes to infinity. And this is how we introduce the idea of continuous compounding. Okay, now let's say that the formula that we had, which is this future value formula, that so far we've been working with different compounding frequencies. Now when it comes to continuous compounding, I will not be able to go ahead and give out a specific period to this this particular M over here, because just imagine how when something is infinity, because this M is for a discrete compounding frequency. Okay, now so far if I have an annual one, I'll keep it as 1. If I have semi-annual, I'll keep it as 2. Maybe if it's a quarterly, I'll keep it as 4, so on and so forth. I can give it out a discrete number to this M. But when it comes to continuous, this goes on for infinite. Okay, so we need something else, maybe a different formula that can actually incorporate this continuous compounding. So the formula for continuous compounding is, as the future value is A multiplied by E to the power R multiplied by T. Okay, now this is a very actually simple and more convenient formula rather than this periodic compounding. And let me also tell you that continuous compounding is something that we're going to be using a lot in the evaluation of options and other derivatives as well. Talking about FRAs, we're going to be working with continuous compounding. Talking about swaps, we're going to be using a lot of continuous compounding. So this is something that you need to know for the exam. Okay, now how do we arrive at this particular formula is that A is the amount that we have, E is the mathematical constant, okay, and this R is the continuous compounding rate. Now I want you to observe that this R is in small case and this R is in capital letter. So this represents continuous compounding and T is the time. Okay, we're going to be solving a practical problem, but let me just tell you that we arrive at this particular formula because this 1 plus Rm, okay, when this M goes to infinity, we have something known as limit in calculus. Okay, now we do not have to get into the calculus to actually derive this formula. Okay, so with the help of calculus we have reached to this continuous compounding formula. All right, so let's take one example to understand this continuous compounding. All right, so here we have the example that we've been working with. The same amount is A is $100, the T is 5 years. They calculate the amount of money if the interest is 5% continuous compoundedly. Okay, now this is the same example that we've been working. So if I want to calculate the future value now, let's just calculate that. So the future value is amount A E to the power R T. This is the formula, and we have A as $100 multiplied by E to the power R is the continuously compounded rate is 5%, 0.05 multiplied by T. The time period is 5 years. Now you will notice that it's more convenient to work actually with this formula rather than taking the M over here, understanding whether it's quarterly, monthly, daily, whatever the compounding frequency is. Okay, it's just one formula, one notation, and you're good to go. Alright, so let's just solve that. So what we do is that we have to first solve this thing here. So 0.05 into 5, that is going to be 100 multiplied by e to the power 0.25. Alright, now this is just an image of the calculators that we are using. Okay, I've just brought an image here so that we understand how do we calculate this e. We're just going to be pressing the 0.25. okay, then we press this second that you key here, and then this ln. Okay, this ln that you see, this ln is, and just above the ln you see e to the power x. So that's where we do it, but we have to first press this second key. Okay, otherwise it's gonna take the value of a log. Okay, so this is just one thing that you need to know. Alright, so this is how we do it, and once we do that, so once we solve for this e to the power 0.25, we get 128.40. So this is the continuous compounded return that we have at the end of 5 years. Alright, so now I have a comparison of all the different frequencies that we have seen so far, and as you can observe that as the compounding frequency as the compounding frequency increases, okay, from annual to semi-annual to quarterly, you will see the amount also increase to a certain extent. Okay, and especially in all these decimal places we do see a difference. And I have also got here the continuous compounding as the comparison. When the compounding is on a continuous basis, we have this as the answer, very much as the daily answer. Now honestly, they'll not be ideally the same, but when you take the decimal places to maybe 3 or 4 decimal places, you will see some minute changes. Okay, moving on to another topic, and that is converting interest rates. So in this, what we're going to do is we're going to find an equivalent rate from the discount compounding to continuous compounding, or I can say that if I have a continuous compounded rate, then what will be the equivalent discrete compounding rate? Okay, we're going to be taking that example, but before that, let's check out some of the formulas that we need to calculate these equivalent rates. Alright, now as you can see, I have these discrete compounding and continuous compounding formulas. Now both these formulas that we have, they both give the final answer as the future value. Okay, so I can rewrite this equation as this, and I can say that this one gives me future value, the right hand side gives me the future value as well. Now these are the two formulas that we have to find the equivalent rates. Now to arrive at this particular formula, we can solve this thing, we can just solve this thing algebraically, and we can find these both formulas. So for example, if I want to find this r, I can just use a little bit of algebra. So this t and this t, they are common, so they both cancelled out. This a and a, this is also cancelled out. So what we on the left hand side, what we are left with is this 1 plus r to the power m, and over here we just have e to the power rc, which is, now this r is the continuously compounded rate. So I can just take this as a common, and I can rearrange that, and this is what I can arrive at. Now you must be wondering, where do we get this ln from? Okay, let me just show you the calculator. Now have a look here. This is the same image that we've been have for this particular calculator. Now over here, as you can see, this ln and this e to the power x, so they both have the same function. So basically log of this value. Okay, I've just taken an example, 1.025. if you find this log, okay, if you press 1.025 and then if you press this log, you will get this as the answer. Okay, and if you find if you just take this 0.024693 and then you press second and e, then you will get this as the answer. Okay, so I can say that this e is the base of this log, and that is why we've taken this log over here, just a replacement of this e. Okay, so don't get confused. So suppose we have 5% rate that is compounded semi-annually. We want to compute the corresponding continuous rate. So basically we want to find this r. Okay, this is something that we need to find. So the formula is the continuous rate that is equal to m multiplied by ln, okay, 1 plus r over m. Okay, this is the formula that can help us to find this continuously compounded rate. Okay, so let's just solve for that. So m is the semi-annual compounding, that is going to be 2. Okay, in a year we have 2 periods, multiplied by ln 1 plus r is 0.05 over 2, and once we solve this thing we get 0.049385. okay, this is the rate, or I can say that 4.93 approximately. This is the continuously compounded rate if 5% is the semi-annual compounded rate. The second example we have here is that we have this continuously compounded rate which is 12% here. Now let's first write down the formula. The discrete compounding, that is equal to m multiplied by e, okay, to the power r, which is the continuously compounded rate, divided by m minus 1. Now this, okay, so m is, in our example, it's monthly compounding. That's what we need to find. Okay, so monthly, that is going to be 12 multiplied by e. The continuously compounded rate is 12%, that is 0.12 over 12 minus 1. And once you solve this thing, okay, you will get 12.06%. This is the discrete, or I would say monthly compounded rate given this 12% of continuous compounding. Okay, so this is a very simple example, not something that you may see on the exam. The GARP will not ask you some such easy calculative questions. Okay, you may have to use this thing somewhere else, but understand that yes, overall what you need to understand about compounding is that there are different compounding frequencies that exist, and one of the highly used compounding frequency is continuous compounding. Okay, so that is something that you need to understand. Okay, the overall process that goes in it, and that is something you need to understand. You do not expect such easy questions to come up on the exam day. All right, okay, moving on, we have another topic, and that is present value and discounting. Now this present value, it's one of the essential concept in time value of money. Okay, when we're learning about time value of money, we talked about future value, right? We have seen how the future value of an amount A, okay, and if you invest it today, what can be the future value. We've already seen that. We have seen formulas, we've seen how to calculate that based on different compounding frequencies as well. But as an alternative, now we can ask how much a certain sum of money to be received in the future is worth today. Now the question here is that what is the value of an investment that we are about to receive in the future? What is the value today? This is known as discounting, or finding the present value. Okay, as I said, when we are in finance, we will come across present values, the future values, the essence of time value of money. Okay, this is something now, and I would say that the heart of valuation, when we're valuing bonds, when we are valuing the options, the derivatives, the heart of the valuation lies in this present values. Okay, and overall the underlying concept is very much simple. It's not so difficult to actually understand these things. Okay, so this is why we need to spend a little bit of time on present value as well. Okay, now this is something that we have already seen, and we've been working with this example here. We had $100 as the investment today, and we wanted to find as basically the future value. So what we did is that we had an interest rate of 5%, so we just multiplied by this 5% for the period of 5 years, right? This is 1, 2, 3, 4 and 5. So by the end we had this 127.62. Now this is something that we had as the future value that we were interested to find. So now the question here is that what if I have this value that I will receive in the future, 5 years down the line. Now what is the present value of this $127.62? What is the present value? What is it worth today, back to day zero? That is what is worth today. So in order to find this present value, all I have to do is that there is one simple algebra that we are doing. Okay, so let me just write it down. So future value, that is equal to this amount, okay, then we multiply it by the rate and then to the power t. Okay, so now in order to find this present value, all I have to do is that I have to take the future value, okay, and then just divide it by 1 plus r to the power t. Okay, so if I solve this thing, I have the future value as 127.62 and divided by the rate, so that's 0.05 to the power t. T is the 5 years, because we are discounting it, or we are getting the present value back to day zero from 5 years, so that is why we have this 5. And if I solve this thing, I will get 100 as the answer. Alright, so this is my final answer. I mean, $100 is worth today, and in the future it's worth 127.62. Now there's one thing that I want you to note here, that this amount that we see here, I can replace this with present value, right? I can write this formula as the future value that is equal to the present value, that is what is worth today, whatever we have today, multiplied by 1 plus the rate over t. And with just a little algebra, I can find the present value as the future value divided by 1 plus r to the power t, and that's what we have this formula. Okay, so essentially both the future value and the present values, they are actually related, and the way to remember this future value and present value is very simple. If you want to go to the future, you will have to multiply by the interest rate, okay, and if you have something in the future that is to be received today, you have to divide it, because of course your money that you have now, it will definitely increase over time, and the money that you will receive in the future is going to be worth less today, and that is why we divide it. Okay, so let's take an example of present value. Suppose $500 is to be received in 3 years, when the interest rate is 4%, has a present value of, so we know that in this 3 year we will receive this $500, and the interest rate that we have, the R, is 4%. So what is the present value? That is, what is the present value today? This is something that we need to find. Now, as I said, the present value is equal to whatever the future value is, okay, in our example it's 500, divided by 1 plus r to the power t. Okay, the future value is 500, the amount is 500. I can even write this future value as amount, okay, so that you do not get confused. I can write it as the amount over 1 plus r to the power t. So $500 is to be received in 3 years. 1 plus, what is the rate, is 0.04%, and to the power t, the time is 3 years. And if I solve this thing now, I'll have 500 over 1.124, and if I solve this thing now, I will have $444.83, and this will be the present value, that is the value today of this $500 given this interest rate. Okay, so this is how we can find the present value. Let's solve another example. Now I have this $500 that is to be received in 3 years, when the interest rate is again 4%, but it's now compounded semi-annually. And what will be the present value? So the present value here, when we have this thing, as I said, it's going to be amount, okay, 1 plus r divided by m. Okay, the same thing that we had for the future value. So it's 1 plus r over m to the power t multiplied by m. When we have this discrete compounding, okay, except like semi-annually, quarterly, anything like that, we do the same thing. Okay, so it's going to be $500, that's the amount of the future value. 1 plus the rate is 4%, divided by m, it's semi-annually, so it's going to be 2. 3 years is t multiplied by m, that is 2. Now if I solve this thing over here, that is 1.126, and finally I will have 444.04 dollars. This is going to be the present value if we are compounding it semi-annually. Now there's one thing to note here, that when we are compounding it annually, we get 444.83. okay, this is the amount that we get here, and when we are compounding it semi-annually, we are getting it less. Okay, so this is one thing that I want you to note, that when we are talking about future value, okay, we are multiplying, right? So we will receive more if we are compounding, if we increase the compounding frequency, okay, and if we are taking the present value, we will receive less if we increase the compounding frequency. Similarly, if I, let's say if I want to compound this quarterly, okay, the same 4%, if I compound it quarterly, this amount will again go down. Then if I compound it monthly, again it would fall down. Okay, so overall this is something that is need to be noted. Alright, so with this we finish with our different compounding frequencies. We have talked about present value, future values, and continuous compounding as well. Hopefully you have learned a lot in this video, and we will meet in the next video. So make sure that you subscribe to our channel if you haven't subscribed yet. Alright, thank you so much for your time. Have a great day.